Standard forms, we can identify the vertex, the focus, the directrix, and get a nice sketch of your graph. So these are the two equations that we're going to be working with, and we're going to be talking about how to put them in that form so that we can get a nice sketch. Now, keep in mind, when we talk about a parabola, what a parabola is, it's the set of all points that are equidistant from a given point called the focus and a given line called the directrix. So, for example, if I had a point right here, the distance from that point to the focus would be the same distance as that perpendicular distance to the directrix. And as you get further and further out on the parabola, the distance to the focus gets longer, but so does the distance to the directrix. But those two distances will always be the same. So that distance right there from the focus to the vertex, we call that distance P. The distance from the vertex to the directrix, that's also equal to P. And you'll see that coming into play in both of these equations. So let's go through two examples. I'll show you how this works. The first thing you want to do is identify what type of form this is in. Is it a y-squared type or an x-squared type? Well, it looks like this is going to be like a y-squared type, so this is the form we're going to be trying to get it into. So let's get everything that has a y on the left side of the equation, and everything that doesn't have a y, let's move it to the right. So we're going to add 4x to the right, subtract 29, and then now what we're going to do is we're going to complete the square. So we're going to take half of b.
Whamble! Okay, I wish I was there. How annoying.
Nearly a billion people around the world experienced hunger last year.
Square. So we take half of this coefficient, half of 10 is 5. If we square that, 5 squared is 5 times 5, that's 25. If we add 25 to the left side of the equation, we want to add it to the right to keep it balanced, right? Now what we're going to do is we're just going to factor this left side. And the way this factors, it's going to be a perfect square, a binomial square, and it's going to be y plus 5, the quantity squared. It'll always be half of this b value. If this was minus 10y, you see this is y minus 5. So that's kind of a quick shortcut. And you can always check the work if you write y plus 5 times y plus 5 and fill it out to get back that original. Now over here, if we simplify, we get 4x, we get 29 plus 5 is negative 4. And then what I'm going to do is I'm going to factor out this coefficient here in front of the x. So in this case, I'm going to factor out a 4. And that's going to leave us with x minus 1 on the right. And on the left, we have y plus 5 quantity squared. Okay, so now we have it in this form. And we can identify the vertex. Now, what you want to be careful of is you want to make sure you take the x coordinate of the vertex and group with the x, so that's going to be positive 1. And the y coordinate of the vertex is grouped with the y, that's going to be negative 5. Also notice that the signs are flipped. So if this is negative 1, this is positive 1. If this is positive 5, this is negative 5. Just remember, x is with the x and the y is with the y. Now let's go ahead and graph this. So 1, negative 5 puts us right here. That's our vertex. And we have to kind of now identify, is the graph going to open up or down or right or left, right? And when it's a y-squared type, and this p-value is positive, it opens to the right. If the p-value is negative, it opens to the left. So the way we find p is we take this coefficient here, 4, and we set it equal to 4p. So let's do that. 4p equals 4. Divide both sides by 4, p equals 1. Notice it's positive, so our parabola is going to be open to the right. So if I go one space to the right, that's our focus. And so that's going to be at 2, negative 5. And if we go 1 to the left, that's going to be our directrix. And that is the line x is equal to 0. X lines are vertical lines. So we can see that this distance from the vertex to the directrix and the vertex to the focus is the same. That's our p distance. That's 1 and 1 in this case. Now the other thing is that the parabola keeps getting wider as you go further and further out, right? But at the level of the focus, it's always going to be 4 times p.
That's the lattice rectangle. They talk about 4p.
And in this case, 4p is equal to 4. So what I'm going to do is I'm going to cut that 4 in half. I'm going to go up 2 and go down 2. And that's just a way of getting a couple of easy points to locate on your parabola. Of course, you can see it's getting wider. But this distance right here is 4p. So let's go ahead and take a look at another example. Okay, let's try example number 2. If you're getting the hang of this, maybe you might want to try this one.
Okay. That's enough to look at, and then we'll go to our notes next.
Why would you have 3?
Because the full distance across was 4p. So if you want to find 2 points, you'll go 2p on each side. Okay, let me get notes out. And you might, while I'm bringing around notes, go ahead and get out your little formula sheet that has the parabola with stuff on it there. Alright, so here's our basic setup for our parabola equations, and these are called the standard form of the equation. So you have not dealt with this form of the equation before now. So, like I told you already, and like you mentioned in the video, you can actually have an upward, downward, right-facing, left-facing parabola. If the x is the squared variable, that's what you've dealt with up until now, then it will be an up or down parabola. And the value of p determines if it's up or down. So if this coefficient here is positive, it goes up. If that coefficient is negative, it goes down. Okay, well, if the y variable is the one that is squared, that's when we get a left and a right opening parabola. Again, the value of p determines if it goes right or left. If p is positive, it opens right. If p is negative, it opens left. And so here you have all these little pieces that we've mentioned. Of course, you've dealt with a vertex before. This line here that is outside the parabola is called the directrix. It's horizontal over here, but it's vertical over here. We have the vertex, then we have this focus. We've used that term before with the ellipse and the hyperbola. Of course, you just have one here, not foci, but focus. And this distance from vertex to focus and from vertex to directrix is equal, and that's the value of p. Then you have this thing called the latus rectum here, the focal width of the parabola, how wide it is at a point that goes through the focus, and that length is 4 times p. Okay? Then, like we mentioned before, you have that axis of symmetry that cuts through the very middle of the parabola. All right, so some of those terms you've used before, some are going to be new. Let's take a look at it in the notes, and then we'll talk about how to graph them today. All right, so here's a basic upward-facing parabola. It is the locus or location of all points such that each point is equidistant to a fixed point called the focus and a line called the directrix. So if I took any point on the parabola and found the distance to the focus and found the distance down to the directrix, those two would be equal. Those are the points that determine the parabola. So these two distances here, D1 and D2, would always be the same. All right, so let's label some things on this upward and then the rightward one. Okay, the vertex that you probably already know is located there. Let me make this a little bit larger. Do y'all see the little, there it is. Okay. Here we go. Okay, so that's our vertex. This is the focus. This line right here is the directrix. And then this distance here is P, and so is this. And then this distance is what we call the latus rectum. I don't know how many times I'm going to have to say that today. And it is the length of 4P. Okay, so all this translates over here as well. This is the vertex. This is the focus. This is directrix. Oh, I left out one line over here, our axis of symmetry. Let me point to that. Axis of symmetry. But on this one, the axis of symmetry is horizontal. Distance of P is here and here. And then that distance all the way across is 4P. So that means that we have 2P here and 2P here. 2P, 2P. All right, so those are all the terms that we will use. Notice that the focus is always going to be inside the curve. When I say inside it, like think of a parabola like a cup, right? So whichever way it's turned. And the focus is inside the cup. So the focus always lies inside the parabola. The line out here, directrix, is always outside of the parabola. The directrix and axis of symmetry are always perpendicular. The vertex is P units away from the focus and the directrix. And I put absolute value of P because sometimes our P value will be a negative number. And that will just indicate the direction that it's opening. The blank is a segment that passes through the blank with endpoints on the parabolic curve and has a length of that. Okay, the latus rectum, there we go. Totally messed up that. There we go. Is a segment that passes through the focus with endpoints on the curve and has length of 4P. All right, so let's put our standard form on here. This is for the vertical, so opening up and down. X plus h squared equals 4P y minus k. And then if it's a left or right, we call it a horizontal, and that's y minus k squared equals 4P x minus h. Okay, if it's vertical, it will open up if P is greater than 0. That means P is positive. It will open down if P is less than 0 or negative. Okay, if the y is squared, that's a left and right parabola, it will go right if P is positive, and it will go left if P is negative. Question? All right, let's see how to graph some. All right, so this is all the good stuff we're going to find over here for it. We'll start out by, let's just determine if this is going horizontally, left or right, or up and down. So if x is the squared variable, you'll see what I mean by that, right? If I FOIL that out, I'll get an x squared. So if x is the squared variable, that's an up or a down parabola. Okay? This coefficient is positive. That coefficient is positive. It will open up. Okay, so this is an upward facing parabola. So I'll just put that as my little reminder. What's the vertex? Where's h? Where's k? H is with the x, k is with the y. So 4, -3 is the vertex. Just like finding the center of a circle, the center of a hyperbola or an ellipse. Same process. Okay, so let's go ahead and plot that point. 4, -3 is down there. Okay, we established that it's opening up. So the next thing that I would want to find is this value of p. So looking at that equation, whatever the coefficient out there is, that's 4p. So this number right here is 4p. Well, what is p? What is it? 1/2. Yes, I know. Your brain wants to make it 2, doesn't it? Okay, so that means that from this, let me go back to the picture that we drew. From the vertex, I'm going up 1/2 to the focus and down 1/2 to the directrix. That's not very far, is it? It's going to be hard to indicate on here. All right, so I'm going to say up 1/2, there's the focus. Down 1/2, and the line that goes through that is the directrix. So this is directrix over here. Okay, think about this. If this vertex is at 4, -3, but I went up 1/2, what's that ordered pair? 4, -2.5. Do we need to go through that again? So this was down at -3, but if I jump back up 1/2, then I'm at -2.5. Okay, well, if I'm at the vertex of 4, -3, and I drop down 1/2, what's the equation of this line? There we go. Y equals -3.5. So I started at the focus, dropped down 1/2 a unit. So I went from -3 down 1/2, puts me -3.5. It's a horizontal line, so that equation is y equals -3.5. Okay, well, axis of symmetry, that's going to cut straight through the focus and the vertex and be vertical. So if this is the axis of symmetry right here, what is the equation of that line? X equals 4. And then let's find these two endpoints here, and then we'll be able to graph it. Okay, so remember P was 1/2. So I am going right 2P and left 2P for a full length of 4P there. So if P is 1/2, then 2 times that is just 1. So that means I am going right 1, this is from the focus, and left 1, and those are 2 points that my parabola travels through. So I can just sort of sketch it from there. Okay, so what were those 2 order pairs that we plotted? Well, this one is 5, -2.5. And this one is 3, -2.5. And those are all the little pieces that we need. Good, bad, question, comment? So remember, this distance is P, and this distance is P. But when I go over and find an ordered pair, I go 2P in each direction. So I went up P, down P, right 2P, left 2P to find all those important little pieces. Question? All right, let's jump into the next one then. All right, first thing we got to figure out. This is a y squared, not x squared. Therefore, it is going to be a left or right parabola, not up or down. Okay, so it's a horizontal. Look at this coefficient right here. That's the 4p. That's positive 2 for the p-value. If p is positive, then this opens to the right. Opens to the right. All right, where's the vertex? 0, negative 2. All right, so I already found P. Let's plot 0, negative 2. There's the vertex. It opens right. So, one more little reminder here. I'm going to go right P, that puts me at the focus. Left P, that tells me where the directrix is. So I'm going to go right 2. There's the focus. I'm going to go left 2, and here is my directrix. What is the ordered pair of the focus there? It looks like it's 2, negative 2. Okay, the directrix is this green line that I graphed. It's vertical, so the equation is x equals, but what does x equal there? Negative 2. The axis of symmetry cuts straight through the focus and the vertex, perpendicular to the directrix. So that line is horizontal. It's y equals negative 2 also. And then the last thing we need to do is go out from the focus to P. P was 2, so 2P is 4. So I'm going to go up 4, down 4, and that will give me 2 points to draw the curve through. So 1, 2, 3, 4. 1, 2, 3, 4. And this one is wider than the other one. And that's what the parabola will look like. Now, the ordered pairs that I just connected there would be 2, 2, and 2, negative 6. Thank you. Question? Not too bad. Alrighty. Vertical or horizontal for this one? Up, down, left, right.
Left, right.
Left, right, because y is the squared variable. Okay, if this is a negative 16 out here, that's 4p. So what is p? Negative 4? Okay, so the fact that y is the squared variable, but p is negative, tells me this will open left. Okay, vertex is what? 5, 1. Let's plot it. 1, 2, 3, 4, 5, 1. Remember, it's going to open left, so everything's going to be going this way eventually. All right, that p-value of 4, I'm going to go this way 4. 1, 2, 3, 4. That is my focus right there. And then I'm going to go this way. 1, 2, 3, 4. That will be the directrix. Okay, so the order pair for focus looks like 1, 1. The equation for the directrix, that was 9. X equals 9. Axis of symmetry cuts straight through focus and vertex. So that equation is y equals 1. And then from that focus, we need to figure out what 2p is. So 2p is 2 times negative 4. Kind of ignore the negative. Tells me I'm going to go, oh wow, this is really wide. I'm going to go 8 from the focus up, 8 from the focus down, and then connect it through those 2 points. And it's going to be super wide. And those 2 order pairs that I just drew through would be 1, 8 and 1, negative 8. Did I miscount? My bad. My bad. Thank you. I was looking at it like it was on the axis, but it's not. Alright, let's fix that up. 1, 9 and negative 7. Is that better? Thank you. Oh, you know what? And that one's not in the right place, is it? There we go. Now it is. Question. All right. Let's see. Let's let you do one of these on your own while I do it as well. But whoa, which looks worse? Either? How about 4? You got a fraction and a negative out front. Okay.
Yeah.
Is it in the right form?
No.
No. I actually want that squared thing by itself. So how do I get rid of the negative 1/4 out front?
Add it.
It's not being added. Divide by negative 1/4. Okay, but dividing by negative 1/4, can't I just multiply by negative 4? And that's a multiplication there. Okay, because what is negative 4 times negative 1/4? 1. So, x minus 2 squared is over there. I'm going to put the negative 4 in front and then the y minus 4. Okay, make sure you're okay with that. Okay, you go from there. I'm going to work through it too, so if you need to look up here, check and see. And let's hope I don't make a mistake. Sure. Because the x is the squared variable, and if the x is squared on the front page of the x is the squared variable, then it's an up or down. Y is the squared variable. We change that to a minus. Yes, exactly. So I did that wrong. Yes, already made a mistake. Awesome. Off to a good start today. Okay, check up here. Are we good on this one?
I'm good.
John's good. About the rest of us. Some are still working, so we'll give them a chance to finish up.
So, when you multiply this by 2, you go from
Go from the focus, right?
class is short every day.
You like it being short?
Yeah, all the time.
We should just get out at 2 every day. I can live with that.
We'll have an extra 30 minutes and 4 extra weeks of summer. Okay, nice.
Alright, is anyone still working on this one? Okay. Alright, so let's do 2 more and call it a day. How about that? Okay. Alright, so what we're going to do for 6 through 9 is complete the square to put it in the right form. So we're pros at this now. Let's do one that's horizontal, one that's vertical. About just 8. Let's do 8 and 9. Okay. Alright, so for number 8, what's the squared variable? X. That means that this is the form that I want it in. Okay, so I'm going to write this out here. X minus h squared equals 4p y minus k. That's what I'm shooting for right there. Okay, well what that basically tells me is I want anything with an x on the left and anything else on the right. So x is on the left. X squared plus 2x. I'm going to move that negative 20y and the 61. X is left, y is right. And constant right. Okay, now we're going to do the completing the square part. So we're going to take 2, divide it by 2, which is 1, square it, and we get 1. So next step, I'm going to add 1 to both sides. I'm just going to go ahead and make it minus 60. Are y'all okay with that? I did plus 1 there. Okay, now we're actually almost done because I just want to factor the left and then bring out that coefficient on the right. So what I'm going to bring out is whatever's in front of y, in this case a negative 20. Okay, so what are my factors on the left? X plus 1, x plus 1. So we write that x plus 1 squared. I'm going to bring that negative 20 out front, and that becomes y. What goes here? Close? Plus 3. Because I'm factoring out the negative also. So if I distribute this, then distributing that negative gets me the negative 60. And that's it. Okay, one more. All right, so this one, the y is what's squared. I'm going to put the equation that I want above it, since we're not doing number 7. So if the y is squared, this is what my equation will look like. The y minus k squared equals 4p x minus h. So that's my goal, is to make it look like that. Okay, so in this case, I'm going to put everything with a y on the left, everything else on the right. So leave the y squared, subtract the 14y. We can go ahead and leave some space. Move the 2x, keep the 45. So sort it out, y's on the left, everything else on the right. What's half of negative 14? What's negative 7 squared? 49 added to both sides. Factor the left. Y minus 7. Okay, let's simplify the right. I have a negative 45 plus 49 becomes plus 4. And then my final step is to just factor out the 2 on the right-hand side. And that's it. Not too shabby? All right. What if we had 2 homework problems? Does that sound good? Just 2. I'm going to give you one graph, and I'm going to give you one completing the square.
I'll do the whole packet.
Oh, overachievers. Heads up, we'll finish working with parabolas on Monday. We'll write equations of parabolas. On Tuesday, we will have a quiz on just hyperbolas and parabolas, just like we had an ellipse and circle quiz. Okay? And then we'll wrap up this unit next week, and the following Tuesday, I believe, will be our unit test. All right, let's decide which 2 problems. Let's do number 2. And then on the other side, let's do 7. It's got a lot of stuff in it. All right, I'll buy that. 7. 2 and 7. That's it. 2 baby problems.